Okay, so we're looking at this integral. The first thing that you should notice is that we do have a discontinuity. Okay, we have a discontinuity here at x equal to positive 3. We have division by 0, so we're going to have to deal with that. And this makes it an improper integral type 2. So the first thing, let's introduce our parameter. We can replace 3 here by t, and then we'll take the limit as t approaches 3. The only thing that we have to check is it going to be approaching 3 from the left or from the right? Okay, and again, if you have any uncertainty for this, we know our original integral was 3 to 9. We needed to stay away from 3. So we introduce our parameter here to the right of 3, and then t will be approaching 3 from the right. Okay, so it's going to be t approaching 3 from the right as our limit. And that's fine. We don't need this anymore. We have set up our limit, but you do realize now that inside we have to figure out a way to integrate this. It is going to be, unfortunately, a trig sub. Okay, so we do have x squared minus a squared, and so the sub that we'll be making is going to be x equal to a secant theta, with a being equal to the positive square root of 9, so it'll be 3. So we have x equal to 3 secant theta. Dx will be 3 secant theta tan theta. That's the first part, that's our trig sub. Now let's take a look at this radical in the denominator. So we have x squared minus 9. If we sub in x equal to 3 secant theta and simplify, you should end up here with 3 times tan theta. So now let's go sub everything in. We have limit as t approaches 3 from the right. In the numerator, we have just dx, and dx we know is just going to give us here 3 secant theta tan theta. D theta, which now that I say it, I did forget to put in here the d theta on the side. Okay, so we have our numerator. Let's take a look at the radical in the denominator. We know that's going to simplify and give us 3 tan theta. And now the only thing we have to deal with is our limits of integration. Okay, we did a substitution here. We went from x to theta, so we do need to adjust the original limits of integration, or we could actually instead leave them in terms of x. Okay, so we'll have here our original limit was x equal to t, and we're going to x equal to 9. Okay, and at the end, unfortunately, we'll just have to come back from theta to x. So fine, we're going to simplify, and then we can integrate. Let's get rid of the 3. Let's get rid of the tan thetas. And all that we end up with is limit as t approaches 3 from the right. We have integral of just secant theta d theta from x equals t until x equal to 9. The antiderivative here for secant theta we know. So we're going to get ln absolute value secant theta plus tan theta. And we're going to be evaluating that from x equals t until x equal to 9. Okay. Now we plug everything in, and we have to go back from theta to x. So first off, looking at secant theta and at tan theta, we want to go back to x. And to do that, we always go back to the same place. After having done a trig sub, we're going to go back right here to our original trig sub. Okay, if x is equal to 3 secant theta, That means that secant theta is x over 3, and one way of doing this then is to sort of set up a right triangle, and we know that if this is a right triangle, then this over here, if that's theta, secant is the reciprocal of cos, so x over 3 is actually going to be hypotenuse over adjacent. And let's give ourselves a little bit more room here. That means that this third side will be x squared minus 9, okay, x squared minus 3 squared, which you should definitely recognize that is the original term that we started with, right? And for a trig sub, that's very much what we expect. So we have our reference triangle set up. We wanted to know what is secant theta and what is tan theta. Well, secant theta, we can tell right from here. Secant theta is just x over 3. Tan theta, we could use our reference triangle. There's other ways of doing it. Okay, if you remember, we do already know a relationship right here between tan theta and x. Okay, but using our reference triangle, we can also get that tan theta is going to be opposite over adjacent, so it's going to be square root x squared minus 9 divided by 3. Okay, that's our tan squared term, or sorry, our tan theta term. Now we know tan theta, we know secant theta, we can go and plug it in. So we have ln secant, we said, is x over 3 plus tan, which was square root x squared minus 9 divided by 3. And we are evaluating this from t all the way until 9. So let's plug that in. So first plugging in 9, we have ln of 9 over 3 plus square root squared minus 9 over 3. And from this, we're going to be subtracting what we get when we plug in t. So that's going to be t over 3 plus square root t squared minus 9 over 3. And fine, now we're going to look at it. We're going to have to evaluate our limit. And so we can see here, as t approaches 3 from the right, this limit is defined. And this term here, as t approaches 3, it's going to go to 0. Okay, we have 9 minus 9. This term here is going to approach 3, which means this whole thing here is going to approach positive 1. And we do know that ln of 1 will be 0, so this whole second term is just going to approach ln of 1, it's going to approach 0. Okay, so let's take a look. Really, what we end up with is ln of 3 from the first term here, plus the square root of 81 minus 9, so it'll be the square root of 72 over 3, and it's going to be minus ln of 1, so the whole thing is just this constant. The limit exists, and therefore our integral is convergent. And that is the value that it converges to. So going back to our area, this area is in fact finite. Okay, even though here the height goes to infinity with that vertical asymptote, you can see that the width goes to 0 very, very quickly. Okay, and so the total area actually converges. Okay, next time we'll take a look at another type 2 improper integral.